Okay, this is from your 2003 exam. These are the numbers that I gave you, and so I might make a video with all of these numbers. Okay, so number 5. You've skipped very few problems now. You can do almost the whole thing. So number 5, I don't know what that, okay. On number 5, you have the integral from 0 to pi over 4 of sine x dx. This one's super simple integral. Just be careful going backwards. The antiderivative of sine going backwards is negative cosine x from 0 to pi over 4. So you get negative cosine of pi over 4 minus negative cosine of 0. I've said a bunch of times, don't neglect filling in 0. Some people probably did and just got negative root 2 over 2. Answer choice A, but this is minus a negative 1, so this would give me plus 1, and so it would be answer choice D. I actually haven't checked all my answers, so let's look at this. Let me check them as I go. Let's see if this gives it to me. Alright, so number 5D. Alright, so far so good. Alright, number 9. Number 9. We have f of x is equal to the natural logarithm of x plus 4 plus e to the negative 3x, and we want f prime of 0. So to find f prime of a logarithm, you say 1 over u, x plus 4 plus e to the negative 3x. So you say 1 over that. While you're down there, you always say ln of the base, but this is base e, and then times the derivative using the chain rule of this. 1 plus the derivative of 4 is 0. The derivative of an exponential function is you copy it down, e to the negative 3x. While you're there, you say ln of the base, and then the derivative of the exponent. Copy it down, ln of the base, the derivative of the exponent. And now I'm going to fill in 0. I'm not even going to try to clean it up. I'm going to go in and fill in 0 right now. So I have 0 plus 4 plus e to the 0. ln e is 1. So this is times 1 plus e to the 0, which is 1. ln e is 1 times negative 3. Alright, so that gives me, notice this is 5, 1/5, and this gives me 1 minus 3 is negative 2, so I'm getting negative 2/5, which I got A. So let me check that. Whoever this person is that worked it. Number 9, A. Okay. So let's go to the next one, which is number 17. Number 17. Alright, so f of x is 2x e to the x, and we want to know when f is concave down. So I need the second derivative. I'm going to have to use the product rule first, times derivative of the second, plus second times derivative of the first. The derivative of e to the x, an exponential function, you copy it down, then you follow it with ln of the base, ln e is 1, and the derivative of the exponent is also 1. So you just get e to the x. Then second, and the derivative of the first is 2, using the product rule. And so you might as well just leave it like that. A lot of times we'll factor when we're looking for critical numbers, but right now I just want the second derivative. But you do want to see if you can simplify it some. Alright, so now another product rule first, times derivative of the second, plus the second, times derivative of the first, and this one's just a coefficient. You don't need the product rule here. Coefficient of 2 and the derivative of e to the x. You copy it down, ln of the base, the derivative of the exponent. So you should get e to the x right here. All right, so now I know my second derivative is 2x e to the x plus 4 of these. And then we go through negative exponent, don't have any common denominator, don't have any fractions. Our third thing that we run into is to factor when we're working with derivatives. So I'm going to factor out a 2e to the x, which here leaves me x, and here leaves me 2. So my only possible point of inflection is negative 2, because it makes my second derivative equal 0. This part can't be 0. E to the x never equals 0. E to the x looks like this, exponential function. All right, so now let's figure out before negative 2. So if I fill in a number before negative 2, this factor is negative, and this factor is always positive. See me about that if you don't understand, but that would be negative. And then after 2, negative 2, this would be positive, and this is always positive because e to the x is always positive. And so that tells me my original function is concave down from when x is less than negative 2. So 17, when I check it, should be A. Let's see, where are the other answers to this? Okay. I've never gone to this site, so I hope this guy's right. Or girl. Let's see. 17A. Okay. All right, next on our list is number 19, 22, and 23. So I'll carry it over here. All right, so on this side we're going to have 19, I think it was 22 and 23. 19, 22, and 23. All right, so 19. 19 is a curve, has a slope, so y prime is 2x plus 3. So you have some curve, that's why it has a variable slope and not just a set slope, because it's the curve. So its slope is 2x plus 3. Which of the following is an equation for this curve? Now some people were thinking they were asking for the equation of a tangent line, but they're not. They're asking for the equation of the curve. By the way, the equation of the curve has got to be some form of x squared, because this derivative has this like 2x in it. But to actually find y, find the equation of the curve, I'm going to integrate 2x plus 3 dx. And so that's, or take the antiderivative, you don't even really have to write that down. To go backwards from y prime to y, I'm going to take the antiderivative, 2x squared over 2 plus 3x plus c. So y is x squared plus 3x plus c, which pretty much narrows it down to choice 2, but let's check it, because it also has to go through the point 1, 2. So I'm going to fill that in. When you're given a point, you're filling it in into the original. So I get 2 is equal to 4 plus c, so c is negative 2. So going back to this, by the way, we'll talk about this more in the next class. Also, this is called differential equations. Number 22. We have this thing like this. This is 6. This is f prime of x. This is 1. And so we know this is y equals f prime of x. The graph of the derivative of f is the line. We know f of 0 is 5, and we want f of 1. So I'm going to do what we've been doing on our worksheet. I'm going to integrate f prime from 0 to 1, and that'll give me f of 1 minus f of 0. And so this is all positive. So I have 1/2 base times height. F of 1, f of 0 is 5. So this is me 3 plus 5. So f of 1 is 8. Answer choice D. Number 23. This is the second fundamental theorem of calculus, the FCT2, where if I have an integral from 0 to x squared of sine of t cubed dt, and then I take the derivative of it, these basically cancel each other out. But let's remember what we're going to do as we do that. We got to be really careful. Now, first of all, the reason this is out here is if I integrate this, it becomes a function of x when I fill in the top and the bottom. So this is when I've talked about, I've got a derivative right here. I take the antiderivative, and then they tell me to take the derivative again. So I pretty much end up back where I started from. So these sort of cancel each other out, and I do come back to the sine of something cubed minus the sine of t cubed. But while I was over here, I filled in x squared and 0. So on the way back, I go back to the same derivative, but with a chain rule. So this is what we're going to do. Okay. All right, so what you do is these cancel each other out. Put in the top times derivative of the top. Put in the bottom times derivative of the bottom every time. That knocks this out, and our answer is 2x sine of x to the 6th. Second fundamental theorem of calculus. By the way, that was answer choice E. If you have a derivative of an integral, let's say it has like the bottom is some expression like w and the top is some expression like u, and you have g prime of x dx. These wipe each other out, and you go back to g prime of x. But you have to compensate for while you were taking the antiderivative, you put in u. So on the way back, taking the derivative, you have u prime. And then w and w prime. And again, let me know if you want to talk about that some more. All right, next on our list is 76, 82, and 83. Okay, so we're into the 70s. You should have almost everything worked in your packet. We have a few problems we haven't learned how to do yet. 76. A particle moves, so its velocity is 3 plus 4.1 cosine of 0.9t. I wish I had my calculator so I could show you this, but what is the acceleration? Do not try to take the derivative of this on a calculator active problem in the 70s with decimal answers. So what I'm doing right now is I'm typing the velocity into my calculator, and I want to take the derivative of it to find the acceleration. So when I'm typing in my calculator, you would not write this on your paper. You would always say that you were taking the derivative of v, and you're filling in 4. That's what I'm doing to get acceleration at 4. To get it on my calculator, though, I'm doing math 8. So what it looks like is this. Sorry, it's not working on the screen. And so I get d over d, and then I'm going to put in an x. And don't ever write this calculator terminology. Tell them what you're doing, taking the derivative and filling in 4. I'm going to put this function in, 3 plus 4.1 cosine 0.9t, but I'm actually going to use an x. You ought to try it also. 4.1, make sure you're in radians. Cosine of 0.9x. And close that parentheses. And we want to do it when x is 4. So I'm putting in 4. And I get 1.6329, and so I get C, 1.633. All right, 82 is a lot like what we've worked lately. You have -3, and it's coming through A, B, C, and this is 3. All right, so we have the integral of negative 3 to 3 of f of x plus 1 dx. I'm going to distribute the integral, negative 3 to 3 of f of x plus the integral from negative 3 to 3 of 1. This one I can find because this is f of x, so I can integrate it. The areas of each region is 2, so this is 2, this is 2, and this is 2. And so as I do displacement, I end up with all of this is negative 2. And then this one, the integral of 1 is x from negative 3 to 3. So I have negative 2 plus 3 minus negative 3. So I have negative 2 plus 6 is 4. Answer choice C. Okay, 83. Oh wait, 82, I think. I have to stop at 82. Yeah, and then 83. All right, 82. The rate of change of altitude in a balloon is given by r of t is t cubed minus 4t squared plus 6, 0 to 8. All right, let me read it again. The rate of change of altitude. So I wrote r of t was the same thing as a prime. Which of the following gives the change in altitude of the balloon during the time the altitude is decreasing? All right, so I want to know when the altitude is decreasing. If I want to know when the altitude is decreasing, I need the altitude's derivative to be less than 0. And they told me this is the rate of change of altitude. So this is the derivative. We are looking at it right here. So what I'm doing right now is typing t cubed, typing this, because if I'm reading the words, the rate of change of altitude, a prime, this is a prime, I'm looking for that to be negative. So I'm going to my y equals, and I'm typing this in as an x cubed minus 4x squared plus 6. And I'm only going to look at it from 0 to 8. So I'm changing my window from 0 to 8. And my y minimax, I'm actually got it on negative 3 to 3 right now, but I might change that. All right, so I have 1, 2, it comes down like this. 3, 4, it comes back up in here. And you might want to expand this from negative 10 to 10 to get a better look at it. Yeah, so it's coming like this, goes down and comes back up all the way forever. All right, so what's happening here is this is the rate at which the altitude is changing. So the rate is negative during this time. And so if I want to find out how the change in altitude, like the total change in altitude, I want to take the derivative of a prime, of the integral of a prime of t dt during the time it's decreasing. And you can use Calc 0 to find these. This one's 1.572 and this one's 3.514. And I know a prime was r. And I don't even have to work it, but that's what it would give me. So if you integrate the rate during this time, you'll find out how much the altitude decreased during that time. 83. The velocity in feet per second is given by this. E to the t plus t e to the t. What is the average velocity? Average, blah, I don't care what it is, average velocity. Use your average value formula. This is going from 0 to 3. 1 over b minus a. The integral from a to b of velocity equals. So I typed all that into my calculator. 1/3 integral from 0 to 3 of e to the t plus t e to the t dt, and that gave me 20.086, and this accumulation would give me feet, because if you integrate velocity, you go to distance or position, but this is during 3 minutes, so you go back to feet per minute. That's how you get your average velocity. All right, the next numbers. Let's see, that was 83. So we have 84, 85, 88. All right, 84, 85, 88. All right, 84. A pizza heated to a temperature of 350 degrees is taken out of the oven. So the moment you take it out of the oven, it's 350, and placed in a 75-degree Fahrenheit room at T equals 3 minutes. So this is the temperature of the pizza, and this is the temperature of the room when everything starts, when you pull it out of the oven. The temperature of the pizza, so the T prime, we usually use capital T, doesn't really matter. The temperature of the pizza is changing at a rate of negative 110 e to the negative 0.4 t. As Sophia brought up in class, notice this negative is already installed in there, but we'll watch out for it anyway, make sure we get it right. All right, so to the nearest degree, what is the temperature of the pizza in 5 minutes? So without this negative here, or if you integrate this part from 0 to 5 and you don't get a negative, if you just get a positive, you know it's decreased, so you would have to subtract it from this. But what I can really do is say the integral from 0 to 5 of negative 110 e to the negative 0.4 t dt is equal to the temperature of the pizza, T of 5 minus T of 0. When you integrate this, you actually do get a negative, so we feel good about that. And T of 5 we're looking for, the temperature at 5 minutes, and the initial temperature of the pizza was 350. And so T of 5 ends up being 112.217 degrees. And it should have cooled off, so you can think if your answer makes sense. 85 and then 88. 85 is one that I've told you about a few times. The integral from 0 to 4 of one of these functions. A right Riemann sum under approximates, and a trap over approximates. So if I'm looking at A, it goes like this. And this is one that I just suggested you do it from the right, just one long rectangle from the right, and that under approximates. And then a trapezoid, just do one, and it over approximates. And A is the only one that happens on. So A is the answer. If you look at B, B's going like this. So if I do a right-hand Riemann sum, I have this and this. And so if I make my rectangle, I actually am going from the right, it's going like this. And so that over approximates, and it couldn't be that one. And you could try the other ones out. All right, and then 80, so the answer there was A. 88. All right, so we have something that looks like the average value formula. And they tell me this equals 1. I'm going to be very literal here. I'm going to work this algebra problem out. I get 1 over 2 from 2 to 4 of f of t dt is equal to 1. Then I'm going to multiply, so I know the integral from 2 to 4 of f of t dt actually is going to equal 2. So I'm looking for something from 2 to 4 is going to have a displacement of 2. All right, the first one looks like this. Okay, I don't really know how much that takes up, but I know this is a 2 by 2 rectangle around it. This is 2 by 2. So the red part is 4, and it looks like this yellow part underneath from 2 to 4 takes up a lot more than 2. So I didn't think it was A. But I thought I could come back to it. B was kind of, you know, possible because it has this little funky thing right here. Okay. But if I'm using my little 2 by 4 rectangle, sorry, 2 by 2 rectangle, or which is actually a square. Okay, so the part inside the red is 4. And then you might think, oh, I don't know what that little TP does, but it looks like that this part, I don't know, I kind of left that one. I'm like, oh, I guess that could be 2, and I just thought I'd come back to it. Let's go to C. C, 1, 2, 3, 4. C looks like this. Okay, here's our rectangle, which is actually a square. This is 2 by 2. And then I know this part and this part, I can actually see that it's half of it. If I put the 2 pieces together, I would get this part. Plus, you can verify it by saying this is 1 half, base is 1, the height is 2. And so this one right here is 1. That means this one right here is 1. So then you know that it's C. All right, going back to this one. If I actually got half of it, we can see this one's slightly under half of it. And then the other ones don't make any sense. But again, you can see me about that one if I didn't explain that well enough for you. All right, so that was 88. All right, a couple more. So 91 and 92, last 2 problems on the multiple choice exam. All right, so 91, a particle moves along the x-axis, so you have its acceleration is ln of 1 plus 2 to the t. If the velocity of the particle is 2 when t is 1, then the velocity of the particle at time 2 is what? Well, if I integrate velocity, integrate acceleration, because this is the derivative of velocity, so I integrate ln of 1 plus 2 to the t dt. If I integrate acceleration, it'll take me to velocity. So I'm going to do it from 1 to 2, and that'll give me v of 2 minus v of 1. So integrating acceleration leads me to velocity's displacement. I'll punch this into my calculator. You set it up like that in your writing, but in your calculator you're going math 9 from 1 to 2 of ln 1 plus 2 to the x dx. This part gives me 1.3463. V of 2 I'm looking for, V of 1 is 2. So when you add that over, you get answer choice E. Number 92. G of x is equal to the integral from 0 to x of sine of t squared dt. Notice how if you integrate this and fill in top and bottom, it would become a function of x. Okay, and negative 1 is less than or equal to x is less than or equal to 3. On which of the following intervals is g decreasing? It's very similar to another one they've asked on this exam, which is kind of weird. If you want to know when g is decreasing, look at what its derivative is. So you need g prime to be less than 0. Well, if somebody integrated this and got g, that must mean this is g prime right here. So it's very similar to what I've already done. This is g prime. So I'm going to graph sine of t squared from -1 to 3. Okay, so I'm on my graph, making sure I'm in radians. And I'm graphing sine of x squared, making my window -1 to 3. I'm going back and making my y min and max -3 to 3 just because I'm looking for zeros and positives and negatives. All right, it comes in like this and hits, then it goes up, and before 2 it comes down and then crosses again. Sorry. Sine of t squared looks like this from -1 to 3. It hits 0, 1, 2, 3, somewhere about right here, and then somewhere about right here. So it comes down right here, goes back up, comes down, goes up, like that. All right, so where is it? G decreasing. This is G prime. G prime is negative during this time. So I did calc 0 to find these numbers. And this was 1.772. And this number was 2.507. Kind of weird on the same exam. They have questions that are so similar.